Hello and welcome, everyone. My name is Rachel Burson, and we're here with the summer scholars at Carnegie Mellon University, and we're joined by Dr. Carlotta Berry and Mr. Ander Solorzano. The upcoming talk is a very special one within the RoboLaunch series. The RoboLaunch series is looking at ways to create access and opportunities in robotics and highlight that. Dr. Berry is an American academic. She's a professor of electrical and computer engineering at Rose-Hulman Institute of Technology. She's co-director of Rose Building Undergraduate Diversity, Rosebud, and she has been instrumental she's a change maker. Her teaching, research, and presence has changed the lives of countless students and opened doors to new possibilities. We'd like to welcome Ander Solorzano for a formal introduction of Dr. Berry. He is a graduate of Rose-Hulman, a graduate of the RIS program, and of Carnegie Mellon University. And Dr. Berry has touched and changed his life. Ander?
Hi, everyone. I'm Ander Solorzano. I think some of you had the pleasure of meeting me at Astrobotic here last week. Today we're here to introduce Dr. Carlotta Berry, an endowed chair of the Electrical and Computer Engineering Department at Rose-Hulman. I had the pleasure of actually being a student of Dr. Berry. She was absolutely phenomenal. She was one of the leading forces behind my first introduction into mobile robotics, advanced robotics, path planning, navigation capabilities for robotics. And that pretty much segmented or established the foundation that I needed to have for understanding robotics and taking that to the next step when I went over to CMU. So without that, I basically would get into robotics without knowing much. But without further ado, let's get right to it. Dr. Berry, I'll turn it over to you. We're all excited here to hear your presentation. Let you inspire our cohort.
Absolutely. Thank you, Ander, and thank you, Rachel, and thank you, RIS, for having me today. My talk today will be Robotics for the Streets, Increasing Access. And I have attended some of the previous webinars, and I noticed there was a focus on some of the technical aspects of robotics, and I could do that as well. But I thought I would shift gears and talk a little bit about what you do with your robotics and how you can use robotics to benefit society and improve and make it a better place. So one of the things I did during the pandemic that seems to be never ending was I launched a company called NoireSTEMinist. And while I was on sabbatical, I changed the way that I thought about teaching robotics and being an engineering educator. And so a NoireSTEMinist, by my definition, is a way of bringing robotics and STEM to people. They're bringing people to robotics and STEM to educate and diversify the profession, and also to educate and diversify society. So one of the things that we noticed is that a lot of engineering and robotics and artificial intelligence and machine learning is a little bit cloudy to a traditional or a novice user. So a big thing that I think about increasing access is us as a community being able to share the knowledge that we have with a wider swath of the world, because engineering and robotics will be used to improve society and make it a better place. So there has to be a space for that. And that's what I'm going to discuss today. A big part of why I do what I do is because if you still Google engineer or search engineer or look on television shows or social media, this is how people still visualize engineers. Primarily white males, you know, pocket pin protector, tape on the glasses, etc. And we know this is not what engineering is anymore. And even if that's how people visualize it, we need to change that, because in order for us to improve the world and the designs that are impacted by the world, then we need engineering and robotics to reflect the world that we see. So this is what I mean by increasing access for robotics, is what are ways that we can do that and get robots in the hands of non-traditional types of people and students in order to improve the world. So I like to still use this. It's an oldie but a goodie. Hashtag I look like an engineer. And we want engineering and robotics to look like a rainbow. So increasing access means these types of people are now also using robotics and designing AI and designing systems to make the world a better place, because we've all experienced and seen examples of what happens when we don't diversify robotics like this and the types of solutions that we get. So the reason robotics is ideal for increasing this access is because robotics is inherently multidisciplinary. It already draws people from a lot of different disciplines, social robotics, human-robot interaction, people from psychology, sociology, computer science, electrical, computer engineering, mechanical engineering, biomedical engineering. So because there's so many things you can do on a robot, you can ask someone, what is your interest in? Math, physics, whatever, and you can point them to something on the robot where they could be beneficial and they could help that. So the benefits of this multidisciplinary work that is tied to a robot is that because people's divergent interests can still be satisfied by doing robotics work, you can have different types of prerequisites and still do well. You can be strong in programming, strong in kinematics, strong in controls, strong in electronics, but still engage in robotics. And these various hardware and programming abilities can be exploited based upon the person. So like I said before, I always ask whenever I start a presentation, what is a robot? I will get 50 different answers, but on a very basic level, it's just a machine that is designed to do some task, right? So it's some kind of body, it has embodiment, and it has some kind of hardware. It has some kind of software, typically the brain, created with some kind of computer, onboard computer or microcontroller of some sort. It has software for sensing. And then because my area is human-robot interaction, I like to say a benefit of robotics is that it normally will have a mission or a task, and there has to be some level of human interaction, whether it's with the people as it engages in the task, or a remote operator who's controlling it, such as the Mars rover, and you're on Earth and you're interfacing through an interface. But all of these connections together is what makes robotics such a rich area to study, because there's so many opportunities for interdisciplinary and multidisciplinary work. So me as an academic, and this multidisciplinary perspective means I not only teach robotics to my students, but I also use robotics in my service in order to bring more young people to STEM and more diverse people to STEM. And then I also use it for my professional development and research. And what I have found is this is more like a circle, and there is no bifurcating this into one area or another. I can't say today I teach, tomorrow I do service, today I do research. For example, I teach my students in theory, such as Ander. They get excited about it and they go on to graduate school to do research in it, or they get excited about it and they go down to our innovation center and work on it in their robotics club with their robotics team. Or when I'm doing service to teach like young people, VEX and First Lego League, like that top picture is my daughter's old teams, or with the young people at the bottom where we were using Scribbler robots so that they could do drawing. They then get excited about this and they return to their high schools and they want to do more robotics, math, and science. They then go on to college and then education. So what I'm trying to encourage everyone to do is to think about your work in robotics from a holistic approach. So you're not just in a lab or over in a cubbyhole designing a robot to follow a line or drive in a circle, et cetera. And that's disconnected from thinking about how can I design robotic systems that will impact society? So yes, I may be today programming my robot to follow a line or drive in a circle, but how can I take those basic functionalities on my robot and extend that to do something like maybe carry water to a village that does not have running water, right? Or designing a robot that could help someone who's disabled to wash dishes, right? Or cook. So always be thinking beyond what you're designing your robot for how that robot can impact society and make it a better place. So that's what I do here. I do a lot of how do I take my robotics out of the classroom into the traditional and non-traditional spaces and show how we can grow our community to be a bigger impact on society. Another reason that it's important that we do this is because right now, most people understand robotics through the lens of CGI, computer generated graphics, like in movies like iRobot, et cetera, or social media. I just saw one recently on TikTok where they had a Boston Dynamics dog, a DigiDog, and somebody had put a gun on it, right? So a big part of why we need to be involved in these conversations and we need to be the one writing the stories is because if we don't, then other people do it. And I get asked questions in interviews like I've gotten asked before, should robots kill people? And I get asked questions about sex robots and other things that I kind of cringe at. So we need to be in the room so that we're able to lead and guide those discussions in the state of the art and where we see robotics going and disabuse them of, for example, I've had people tell me they're scared of robots because of something they've seen on television or in a movie. So I focus primarily on human-robot interaction because I feel the human has to be an integral part of the loop, which is a field of study to understand and design and evaluate robotic systems for use by and with humans. And it is to develop natural and effective communication between humans and robots. So it's to design these systems to create teams of humans and robots that are efficient and effective and take advantage of the skills of each team member. And this is important for several reasons, not only just from a developer standpoint, but because if our robots are to become ubiquitous in society, it is key that we understand how they're going to interact with people and that they're interacting with people in a way that is appropriate, right? So you have to think about the robot and the human as a system working together where each has their roles. They each have some type of mental model of how the other is going to engage. What are the capabilities of the human? What are the capabilities of the robot? What should they expect from each other, right? When I hold my hand out, I expected that the robot has a gripper and understands to reach its hand out and to take something from my hands. Or if I walk up to the robot and I wave, does the robot understand that means to speak back and say hello? How do they interact? Do they interact with beeps and buzzes or verbal language or with a push button, et cetera? What are the different modes of communication and what are the capabilities for interaction? What can my robot do and not do? What if my robot does not have a gripper? Then me holding out my hand with an orange in it has no meaning because the robot has nothing to pick up the orange with, right? So Asimov's laws, and there was a 0th one added later, are that a robot may not injure a human being or through inaction allow a human being to come to harm. Second law, a robot must obey orders given to it by humans being, except where such laws would conflict with the first one. The third law, a robot must protect its own existence as long as such protection does not conflict with the first or second law. Or a robot may not harm humanity or by inaction allow humanity to come to harm. The reason I bring this up because a big part of a robot's brain and controller is built upon artificial intelligence. And lately we've been hearing a lot about bias in artificial intelligence and ethical or unethical AI. Well, if there's concerns about AI being unethical, then that's going to immediately tie robotics being unethical because you use AI to give a robot some level of intelligence. So someone, probably one of my students, because I'm always getting memes from my students, sent me this one that shows what happens if those first 3 laws of robotics are put into the wrong order. Like, for example, what if number 1 is don't harm humans, and then number 2 is now the robot is supposed to protect itself, and the third one is to obey orders. Then you tell the robot, explore Mars, and it goes, no, because it's cold and I could die. And that makes for a frustrating world because the robot does not obey the human. Or if obey orders is first, don't harm humans is second, and now protect yourself is third. Well, if it's obeying orders above anything else, then that's a killbot hellscape, right? 3 of these are killbot hellscape, I'll go ahead and warn you. What if obey orders is still first, but now protect yourself, don't harm humans? Still killbot hellscape. Protect yourself, obey orders, don't harm humans, still killbot hellscape. Or protect yourself, don't harm humans, and obey orders is last. Now the human can say, I'll make cars for you, but don't try to unplug me and I'll vaporize you. That's a terrifying standoff. So those are different ways of thinking about Asimov's laws. But the way I want you to think about them is in the context of artificial intelligence. So artificial intelligence involves various things, including the internal model of the world, problem solving, knowledge representation, search, planning, and reasoning. So this diagram I have here is called a sensory egosphere, and it was part of my PhD dissertation. And it was a compact way that I used to represent the robot's knowledge and artificial intelligence, where the robot's ego is at the center. And then everything it knows about itself and its environment is somewhere on this egosphere, which is represented as a database that it uses to make decisions. So if its internal model of the world, it could be a map, it could be locations of key objects in the world, and it needs to go find something. Then problem solving may involve path planning, localization. How does it represent its knowledge to itself as well as to the user? How does it search for solutions? Or how does it plan and reason? For example, if I tell the robot, drive to the yellow cone, it may know, well, I need to make a right turn and move forward 500 feet, but there's a blue ball in between the robot and the yellow cone. Planning and reasoning says, don't drive over the ball. You probably can't do that. How do I get around that ball to get to the yellow cone? So these are examples of planning and reasoning. So now, what do these biasing effects of human-robot interaction look like? Well, some of them could be different expectations in communication. The robot is expecting a user to look and communicate in a certain way, and it does not. And the user is expecting a robot to look in a certain way. So in this diagram here, Sarah Connor may have been warned there's a robot coming from the future to kill you. And she does not expect the robot to look like a human being. So it may walk up to her and say, Sarah Connor, and she is unlikely to run away because she may not realize it's a robot. Whereas maybe if it walks up to her and it starts buzzing and it has an antenna on it, she may go, oh, that's the robot that was sent to her. So once again, having this paradigm shift, that's an example of biasing. Okay, how do I do that? I tried to do it on the computer, it wouldn't let me. Oh, okay. Okay, thank you. I'm so sorry. I am out of town. Well, not out of town, but out of my house. I had to go to the library to have my presentation, and she's telling me I need to sign in. I'm going to see if I can get through the talk before I have to sign in though. So in this presence of bias, what happens is you will see things like, for example, somebody releases an algorithm to the community, and if there's not diverse teams involved, then this algorithm, which may have never been tested on brown faces or on women, you will see something like it now has highly pixelated images, and it converts them all and interprets them into some kind of white male interpretation, because that was the standard for the engineers or the people who designed this AI. So what causes these types of things to happen is because there was not a diverse team or a large group of people involved in designing it, or they didn't test it. The user study may not have been diverse enough so that these things could be catched. And if they are not caught before it leaves your research lab, they're going to get caught when you release it to the population as a whole. So other examples, I won't go through this one, but you can find this one on YouTube, is where you design a system that only works with certain types of skin colors. And so this is a video of one where this man was trying to use a soap dispenser and found that it did not recognize darker skin color. So it only worked on lighter toned skin. And once again, a diverse team would have recognized something like this. So then I think we've all seen the documentary Coded Bias by Joy Boumouini. Similarly, somebody had designed this facial recognition system that also did not work on dark skin. So it only worked when she used a white mask. So here's yet another example of how you can create a system that is biased, right? And so although these are AI and machine learning examples, they obviously extend to robotics as well, because you now put this system on a robot. And if this system is on a robot, the robot wouldn't recognize that person either. So how does it find its way into robotics? Well, based upon assumptions, when people collect this data, how this data is filtered, and how do we address instances that may lead to injustice? So here's an example of where it led to injustice when we were using these faulty facial recognition systems, and people were using them for crimes, right? So they were using them in this bad AI on these pixelated or dark images to match up with somebody's driver's license, and they arrested this guy for shoplifting. And he obviously didn't commit the crime, but based upon this bias in the AI, that now leads to injustice against an individual in society. So this is why, as roboticists, we have to always make sure that our AI is fair. And so this means we need more diverse and multidisciplinary teams in a room in order to change the game. So some of the strategies for doing this are, we need more developers, and more developers who consider ethical implications of their work. That needs to go all the way back to college, right? When you're in college or high school, there should be ethics in your classes, in your coding classes, in your robotics classes, in your engineering design classes. What are the ethics of what I'm doing? Educators need to bring up ethics and societal questions in your training. Teams must be diverse to provide unique perspectives and solutions, and researchers must reference that work of diverse roboticists. Black in Robotics actually has a robotics reading list of diverse roboticists so that people can see the work of some of those individuals, and they can discuss that in their work, in their research, or when they're teaching these topics. So some of the next steps for the robotics community are always to promote diversity in developing teams in academia and industry. And when I do talks like this, these are examples of that. Ensure that bias is considered in the research and application of robotic systems, and make bias training and its effect in robotic application and methods, such as mitigating harm, a component of the curriculum. So here's an example of doing this. And when the second video starts, I'm going to run down the hall and sign in, and I'll be back hopefully before it starts. So this is from the freshman design class at Rose-Hulman. And one of the keys to this is that we want to take robotics out of the classroom so that not only the students who are benefiting are the ones in that classroom. So when I say robotics for the streets, that means getting more young people of all backgrounds involved in FIRST, VEX, C-Perch, ball. And if we're places where they don't have the resources for those types of programs, do things like Black in Robotics, where we just teach robotics online through Zoom and workshops and things like that. So I think this video is going to play long enough for me to run down to the library and make sure she got what she needs. Hi, I'm Carlotta Berry, and I'm a professor of electrical and computer engineering at Rose-Hulman Institute of Technology. I first became excited about science when I was in the 6th grade, and I did a science fair project on electricity where I used a light bulb and a battery and wires to show how to make an electric circuit. The cool thing about it is I still teach electric circuits to this day, even though my concentration is really on robotics, and that's what I'm going to talk about today. How does my robot go? So we're going to look at my robot has 2 wheels. What happens if one wheel is spinning, 2 wheels are spinning, if they're not going the same speed, if they are going the same speed? So let's take a look. Here are my 2 robots. If the wheels are going at the same speed, which of these robots is moving correctly? What if only the left wheel is moving? Which one is right? If the left wheel is moving faster than the right wheel, which of these robots is moving correctly? And this is how my robot goes. I hope you've enjoyed. And so what I want you to see here is that as you're thinking about your technical work and the great work it could do for companies and the government, how can it also benefit society? If even, I'm a robotics educator, so this is how I choose to do it. And the way you may do it looks totally different, but think outside the box a little. So another thing that I've started doing that has been a real big hit, I'm pretty hot on social media, is I discovered there was a whole option in Twitter about 2 years ago. And as a professor, that looks like quizzes to me. So I started asking quizzes on Twitter. And although people don't know a lot, well, some people don't know a lot about robotics or engineering or STEM, it's been a really big hit, right? And so I always try to ask questions that I feel are not too difficult, not quite sure, but then I always try to also have an option for people who are like, I don't know anything about this stuff, so, but it's just a matter of getting engaged and having those conversations and being inclusive and getting people talking about something that they may not have known much about before. So in the last year, here's another epiphany that I had. How can I take things that people do understand and integrate them with something that they may not be very familiar with? And I have called this robot slam poetry, right? So I'm going to teach a concept about robotics, but I'm going to do it in the context of either a poem or a song or something else. And so now it's integrating the arts with the STEM. So it's science, technology, engineering, art, and math. And I will tell you right now, it's not about my singing. It's not about my ability to be a world-class poetess, but I'm sneaking in some kind of concept by doing this. So here's another one. Turn the music up in my headphones. Let's meet Harriet Tubman. She's really quite a soldier. What makes her so unique? That's her two encoders. She leads the way to freedom by heading to the north. Encoders let her know how far she's moved back and forth. Her back wheel is a roller to help her move about. Keep low, keep quiet, keep moving as we head up out the south. Make sure you don't get left as she navigates by stars. Show me some respect. I just dropped those robo bars. Robo bars. So of course, everyone doesn't feel comfortable making a complete idiot of themselves to get people excited about STEM and robotics. I don't mind so much, but that's why I said, if this is not your lane, you figure out what your lane is and you do it. And maybe your lane is just volunteering at the Boys and Girls Club to teach a little bit of robotics there. But doing something to make robotics more inclusive is the key to that. So one of the most recent things I've done, I wanted to share with, is this summer, I became an open source hardware trailblazer. And what that is through the Open Source Hardware Association, I have been tasked along with some of the other trailblazers to come up with a guidebook to make open source hardware more inclusive and so that more academics would engage in doing this type of work. And this is a way of doing that. So the way that I'm doing this as one of the roboticists on the team is I'm designing a completely open source mobile robot platform that's made with either 3D printed or off-the-shelf components that would take a user from a novice to an expert level. Because Arduino is open source, I will have a robot with a Mega on it, a robot with an Uno on it, maybe other Arduino microcontrollers, and then show the design process as well as the software development from beginning to end, using things like Fritzing, Tinkercad, obviously Arduino, 3D printing, etc., and make this system modular enough to be modified to add and remove various controllers, sensors, peripherals, appropriate for everywhere from a novice to an expert level, low cost enough, so that people who now maybe have been priced out of the robotics market before now have something that they could use for either outreach for young people, to do robotics on some level at the college level, or maybe even to get ready for advanced research level robotics as well. And so what I plan to do with this is make these robot platforms that I'm calling from Lilybot to Rosybot, a play on the flowers as well as Rose-Hulman, where there's a way to design these platforms to be used, like I said, for outreach, education, or research, where at the most basic level, you're teaching systematic design, systematic problem solving, like for assembly of hardware, programming, electronics, motion control, and sensing. Then at the more higher level, designing the system, senior levels into college, what kind of control architectures, behaviors, navigation, teaming, swarming, all the way up to human-robot interaction, right? But you now have this whole platform here that can be used for all of these things. So one of the things I always try to end with is discussing the work of Black in Engineering and Black in Robotics. They were both co-founded in 2020 during the Summer of Social Justice and the birth of the Black in X movement. And it was when a lot of academics began to share experiences on social media about their life in the academy as a grad student, as a professor, or even people in industry, et cetera. So the goals of Black in Engineering are to bring together Black researchers, professionals, academics, and students in robotics, advocate for more diversity, inclusion, and equity in these organizations, and not just in robotics, but other organizations, just engineering in general. Ensure there's a seat at the table during development, test, and deployment of robotic systems, and amplify and collect voices for social justice. So also to support Black faculty, researchers, practitioners, and students in engineering, serve as a resource for community building, share experiences with implicit bias and systemic racism, provide action items to address racial injustice, and identify and connect with allies, advocates, collaborators, and sponsors. So in conclusion, robotics is great for recruiting diverse populations to STEM, increasing inclusion and access. And the big part is because it is ideal for showing connections between multiple disciplines, so you can draw the interest of many people together. It's a great tool to educate and entice future scholars to transmit, transform, and extend knowledge by bringing in also considerations of societal problems, ethics, and bias, and how those can be addressed in your technical skills. We all know that anyone on this earth suffers from some level of prejudice or bias, but how do we make sure that that does not get injected into our technology? Because we know robotics, AI, and machine learning are going to suffer from some level of bias because human beings have bias in them, but we need to be careful to try to eradicate that or mitigate that in our work, because that bias can lead to injustice. We know these problems can be solved with diverse teams as well as awareness and education. And in order to increase accessibility by providing low-cost, modular, open-source hardware and software for robotics. So in my final thoughts, and I always share something like this at the end, Maya Angelou was my hero. I've learned that people will forget what you said. People will forget what you did, but people will never forget how you made them feel. So think about that in terms of your technology. They may never know the person who's behind the robot. But if your technology gets deployed in society, you want to make sure of how it makes people feel. So the only one who can make sure of that is you. I am now done with my presentation. I am open to questions, but I always encourage you to reach out if you have more. DRCA Berry is my tag or handle on Twitter, Instagram, and TikTok. Or you can also email me at Carlotta@NoireSTEMinist.com or my company, NoireSTEMinist.com. To learn more about Black in Robotics, it's blackinrobotics.org, or learn more about Black in Engineering, it's blackinengineering.org, or to see more of my presentations or media or articles about the work that I do, you can check out my link tree at Carlotta Berry Media. I was really excited this week and last week because Forbes and Black Enterprise both profiled my work with Robot Slam Poetry. So with that, I am done. Are there any questions?
Sorry about that. Can you hear me now, Professor Berry? Thanks very much for your presentation. This is John Dolan. I co-direct the RIS program along with Rachel, and I'm going to mediate the questions. Thanks for the excellent presentation. So are there folks in the room who would like to ask questions about the presentation? Why don't you come on up, Arnav? It'll be easiest, I think.
It's in the video.
Yeah, I guess we should do that. Thanks. There we go.
Turn it off.
Oh, well. There we go.
Oh, no.
It keeps turning itself off. Yeah.
Oh, that's good.
All right, there we go.
Hello.
Hi.
I just have I don't know if it's a little bit of an ignorant question, but
No such thing.
in the slide with Asimov's laws, I was confused on what the difference between like humanity and human beings are in the context of being harmed.
Yeah, so that zeroth law was added later, and I think it's because people felt like one thing could be, okay, my robot cannot drive up to you and shoot you. I know that's really violent, right? So that would be protecting the human being.
Mhm.
But humanity could be like an iRobot where it's now trying to blow up the world, right?
Oh.
So you're still hurting humans, but now you're trying to eradicate them from the earth completely, right? There's a little bit of a distinction. So one of them could be you're trying to hurt a person. The other one is you're trying to build a robot army that's going to go to war against the world, humanity. If that
Oh, I
makes
see.
sense.
I see.
Yeah.
Yeah.
So either way, it's not good for us. That's what you got to know.
That's for sure. Thank you, Dr. Berry.
You're welcome.
Other questions? I do have a question. You'd spoken a fair amount about selecting projects, trying to get involved with projects that have impact, social value, things like that. So I was just wondering what tips you have for students, particularly given that they may be going into graduate situations or back at their undergraduate institutions where people are kind of, well, they have certain funding restrictions, they have certain projects that are going on, and maybe some of these things that folks would be really interested in making an impact on are just not immediately available or obvious.
Absolutely. Well, sometimes you have to pick your poison is a way to think about it. Like, when I was a grad student, I didn't have a lot of flexibility in what I did. I had to do what my advisor wanted me to do. I went to Vanderbilt at the time.
Right.
So I chose opportunities that fed my soul while also working on the research of my advisors, if that makes sense. So I was in a mobile robotics lab, so I did all the research with my advisor, but whenever they had high school groups come through, or if they had high school kids who wanted to come and intern, I always stepped up to do the demos for the kids or to mentor the young people because I knew that my passion was in teaching. So if whatever you're doing, what I highly recommend is look for ways to feed yourself by giving back, right? So my heart is in service. So figure out what your heart is involved in and see if there's a way that you can integrate that into your research and then go pitch it to your advisor. If you're able to get your work done and it won't sacrifice what they need you to do, most people I think would be open to that,
Yep, that sounds good. Thanks. That's good advice. Looks like Tim has a question.
Hello, I have a question regarding this point of defeating bias in machine learning, etc. So you mentioned that one good thing would be to have more diversity in teams. My question is specifically in this direction of machine learning, where we usually have like data sets already collected, and then it doesn't really change much if the engineers using them are diverse, if the underlying data is also. How do we address stuff like that?
I just actually had a conversation with someone about that very topic. I am the editor of a book that's coming out hopefully next year called Mitigating Bias in Machine Learning. And one of the people I was speaking to said one of the challenges, and I won't mention what school it is, but there's a data set that most researchers use from various different schools. And they've most recently discovered that there's bias in that data set that these people are using to train their algorithms. So they were saying, what do you do about that? And I said, well, in my mind, awareness is first. So if you have to use this large data set that is like the gold standard, I think you have to be transparent with your results. And when you share those with people, say, hey, we use X data set to do this work. And we have discovered in the past that it's biased against women or biased against people of color. But in the midst of doing this, we're also working on developing our own competing data set. Just because it's the gold standard, maybe you're the trailblazer who says, I'm going to create my own. Or if you don't have the bandwidth and resources to do that, I'm going to figure out a way to add more data into that data set. But I think awareness is the first step, because you don't want people blindsided. Like I talked about that algorithm that started trending on Twitter when people are like, hey, why is this turning all my pictures into white men? Don't let your stuff hit the streets and people see it first. Say, hey, I've got this new cool algorithm. I warn you, though, it only works on white faces, right? You tell people in advance, but then don't just stop there and say, here's a problem. You start figuring out what are the solutions and how can I make those?
Okay, yeah, great. Thank you for the insight.
Yeah.
Other questions from folks in the room? All right, I think that's it as far as questions go. I want to thank you very much for the excellent presentation, and wish you the best in your continued work in this area back at Rose-Hulman and other aspects of your career.
Thank you so much. Thank you for having me. It was wonderful seeing everyone. Bye-bye.
Thank you so much. Have a good day.
Bye-bye. You too.
Thanks.
Bye-bye.
Bye-bye.